Today I'm going to present my topic constant folding application in compile time computation. It is a part of my active learning from the subject automata and compiler design. In this presentation, I'll explain what constant folding is, how it works inside a compiler, its advantages, limitations, and real-world applications. By the end of this presentation, you will clearly understand how this simple technique helps improve program performance. Before understanding constant folding, we need to understand what a compiler does. A compiler is a software tool that converts high-level programming language like C, Java, or Python into mission-level code that a computer can execute. This process happens in multiple stages. First is lexical analysis, where code is broken into tokens. And the next is syntax analysis, where structure of code is checked. Then comes the semantic analysis, which ensures the meaning of the program is correct. After that, we have the code optimization phase, which is very important. Here, the compiler improves the code to make it faster and more efficient without changing its output. Finally, the optimized code is converted into machine code in the code generation phase. Constant folding is one of the techniques used in optimization phase. The optimization phase is crucial because it improves the efficiency of the program without changing the output. So let's see about what is code optimization. Code optimization is a process of improving a program so that it runs efficiently. The main goals are to improve execution speed, reduce memory usage, and minimize CPU usage. There are two types of optimization. First, mission independent optimization, which works regardless of the hardware, and the second, mission dependent optimization, which depends on specific hardware architecture. Constant folding is a mission independent optimization technique, meaning it can be applied to any system. So let's see what is constant folding. Now let's see constant folding is a compile time optimization technique where the compiler executes constant expressions before the program runs. In simple terms, if there is a calculation in the code that involves only constant values, the compiler computes it in the advance. That means it compiles in the compilation time rather than at the runtime. So instead of performing the calculation again and again during execution, the result is already available. This reduces unnecessary computation during the runtime and making the program more faster, efficient. Let's see how constant folding works. The compiler scans the entire program and looks for the expressions. It identifies expressions that contains only constant values and do not depend on variables or user inputs. Once such expressions are found, the compiler evaluates them immediately. Then it replaces the original expression with the computed results that we have. This process happens during the optimization phase before the program is executed. So, effectively, some part of the computation is shifted from runtime to compile time, saving a lot of time and memory usage. Let's consider this example. So if you look at the example, before the constant folding, the code is written as int x equals to 10 plus 20. Here, normally the addition would happen during the program execution. But let's see, after the constant folding, int x equals to 30. The compiler has already calculated the results and stored it into x. So whenever the execution is started, no addition is again required. So this reduces a number of operations and improves efficiency, especially when such expressions appear multiple times. For suppose if we have uh, such expressions throughout our code, so if we did not use constant folding, then the performance and the memory usage of that particular program would be so high and the performance would degrade. So we use constant folding to compute these expression at the compile time and store these values so that they can directly be used at the runtime without again calculating them. So these reduce the number of operations at the runtime, saving us a lot of time. Let's look at the advantages. So constant folding offers several important advantages. First, it reduces runtime computation because calculations are already done, as we have seen in the example. Second, it improves execution speed since fewer operations are performed during execution. Third, it decreases CPU workload, making the program more efficient. It also helps in generating optimized mission code. In large-scale systems, it can even reduce energy consumption because fewer computations are required. Overall, it contributes to faster and more efficient program performance. Let's look at the applications. So constant folding is widely used in many real-world applications. It is used in compilers for compilers of programming language like C, Java, or Python. It is also used in embedded systems where performance and efficiency are critical, and in high performance computing, constant folding helps reduce computation time. It can also be used in game engines, mobile applications to improve speed and responsiveness. So it plays a key role in modern software system. Constant folding is a part of a broader concept called compile time computation. This means performing calculations before the program actually runs. By doing this, the workload during runtime is reduced. As a result, applications become faster and more responsive. This is especially important in systems where performance is critical. However, constant folding also comes with some limitations. It works only for constant expressions. It cannot be applied when values depend on variables or user inputs. It is also limited when expressions involve runtime data. So it is useful while it cannot optimize every part of the program. So to conclude, constant folding is a simple yet powerful optimization technique. It improves efficiency by reducing unnecessary calculations, as we have seen. It enhances program performance and reduces execution time. Even though it has some limitations, it is it is an essential part of compiler optimization. Thank you for your